So I think this is a field of stars that we looked at earlier in this chapter. It's just gorgeous. And notice that stars have different colors, and I think we've talked about that red stars tend to be cooler, and blue stars or white stars tend to be hotter. We'll talk more about that. But the other thing is that a star's brightness depends upon two things. It depends upon how much energy that star is putting out, wherever it's located, and then it depends on where that star is located, how far away it is from us, because if the star is far away from us, it's going to appear dimmer to us. So it's just, you can think of stars scientifically, which is what we're trying to accomplish in this class, or you can just look at stars and think they're beautiful, and they are totally beautiful. So we use the word luminosity to describe the amount of energy that a star is putting out. The amount of energy per second is what we generally call watts. And back on the previous chapter, chapter 10, I actually gave the number of watts that our sun pumps out. So in general then, I think I might have mentioned back in chapter 10 on the sun, I said that we're going to compare other stars to our sun. So if we look at the luminosity of our sun, that's the energy that our sun's putting out, the most luminous stars out there, now they might not be bright because they're pretty darn far from us, but as far as pumping out energy, 10 to the 6th would be 1 with 6 zeros, or what, 1 million? So the most luminous stars in our galaxy would be 1 million times the luminosity, or 1 million times the amount of energy that our sun's putting out. On the other end of the spectrum, we have those stars that aren't so energetic, and relative to the sun, they're putting out like 0.0001 times the luminosity of our sun. So, you know, there's definitely an assortment of stars out there with regard to the amount of energy, they're putting out. So whenever you see something with a subscript sun, that means compared to our sun. So big L, luminosity, subscript sun, means the luminosity of our sun. Well, there are actually kind of two, I call two brightness scales. There's the brightness scale as to how things look to us, and actually our textbook uses the term brightness for apparent magnitude. So the term magnitude means brightness. So apparent magnitude be apparent brightness. And we use the lowercase m for that. So just to kind of, and I'll talk about this scale in a minute, it's kind of a backward scale, I will warn you. But just in terms of, can you see the scale over here? The brighter the object, the more negative the number. So a negative 25 object is very bright, and a plus 30 object is very dim. So to put some things here, for instance, our sun is, when we look up in the sky, to us, how bright the sun is big. So the apparent brightness, or the apparent magnitude, little m, of the sun runs about negative 26.7, very bright. Okay, full moon, not as bright, negative 12.6, that's still very bright. Venus, I don't know if you've seen Venus this fall yet, but it's beautiful in the morning in the east. It's a negative 4.4. Sirius is called the dog star sometimes, and it's part of the little constellation Canis Major, I believe, and it's negative 1.44. So notice that we're getting smaller negative numbers, and the objects are getting dimmer. The scale was based upon, actually, long ago, a couple of astronomers said what the dimmest star they could see without a telescope, because they weren't using telescopes then even, they gave it a +6 magnitude. That was the dimmest object they could see naked eye. Well, if you use binoculars, you can then gather 4 photons, use little photon buckets, and you can push that to a +10. Pluto runs a +15.1, what we call apparent magnitude, or little m. And the Hubble Space Telescope, because of its large aperture of its it's a reflecting type telescope, and because the Hubble Space Telescope doesn't have the Earth messing with the incoming light, can see objects as apparently dim has plus 30 magnitude. So just to kind of remind you, your textbook, whenever you see the word brightness, that is actually apparent brightness or apparent magnitude. Brightness means what does it look like to us in the nighttime sky? Well, it's important as we look at stars to what we say kind of normalize or remove the effect of distance. We want to be able to consider stars scientifically as if they were kind of all the same distance from us. And in enters then something called absolute magnitude. And the variable we use for absolute magnitude is an uppercase M, sorry, capital M. So what we do then is to remove the effect of distance. It's kind of a thought process to basically move that celestial object a distance of 10 parsecs from the Earth. And when that object is 10 parsecs from the Earth, the way I look at it is we now look at it and compare it on our apparent magnitude scale, if that makes sense. So relocate the object and look at it again, how bright it is. Relocate it to a common distance of 10 parsecs. However bright it is at 10 parsecs, that's its absolute magnitude, capital M. So for instance, instead of being a negative 26, it's the apparent magnitude or brightness, if we were to relocate the sun, heaven forbid, a distance of 10 parsecs from us, so that's over 30 light years, the sun would appear in our daytime sky, or excuse me, the sun would appear in our nighttime sky to be a magnitude of or brightness of plus 4.9. So for that reason then, our sun's absolute magnitude is plus 4.9. So I added, a bit has been added to this, and you'll see hopefully what I mean. So this textbook uses the term brightness, as I said, to describe how bright something appears in the sky. And generally that's called apparent magnitude, and we use a lowercase m for that. The capital M is reserved for absolute magnitude. And absolute magnitude then is removing the effect of distance. So it makes more, it removes a variable, okay? So the big thing here is we talked about luminosity. Look at this second, what we call ratio down here. Luminosity is the amount of energy that a star is pumping out. And it's a star's luminosity then is directly related to this second type of brightness scale called the absolute magnitude of a star or a celestial object. The absolute magnitude then is a direct indication of the amount of energy that a star is putting out. So that's important.